Dear students, welcome to our class on numerical weather prediction 3. Numerical weather prediction 3. In this class, we are going to study and understand components of numerical weather prediction model. Components of numerical weather prediction model. At the end of this class, I also try to enlighten you on M.Sc multi-modal ensemble technique. So far in the first two classes, we tried to understand the definition of numerical weather prediction, then what are how it is superior to statistical models, synoptic models, dynamic statistical models. That's what we call it as the ensemble technique. There are four types of weather prediction models. The first one, traditionally synoptic. In the synoptic, observations are taken. They are sent to a central point, southern zone, eastern zone, western zone, northern zone, and they are decoded. And after thorough analysis and with the experience of the forecasters, wonderful forecasters, with their experience, so from there we started our journey. So synoptic forecasting is there. Then statistical forecasting, of course, I discussed it several times. What is the statistical forecasting? Then ensemble technique. That's why at the end of this class, 2 to 3 minutes, I give you a broad definition of it and then how ensemble technique. So we tried to understand what is the numerical weather prediction basics in the first two classes. Now in this class, first I would like to share with you, dynamical statistical models are there. That's what we call ensemble technique. Now, so what is a dynamic system? This is very interesting. A dynamic system is the one which evolves over time. A dynamic system is the one which evolves with the time. That means as the time progresses, the system, how it is progressing, that's what we call it as a dynamic. So in our professional life also, he is a very dynamic scientist. So he goes with the time to meet the time, he races with his knowledge and hard work. So that is the dynamical. Of course, dynamical statistical model ensemble, that I discussed with you at the end of this class. Here, now, see, in the dynamical system, there are two things there. Number one, you need some rules. So initial conditions are required for the dynamical system, perfect initial conditions. So once you know those initial conditions of the system, then when you go for analysis, the variables, or you can say that dependent variables, not independent, dependent variables, so how they are giving dependent variables of weather, how they are giving the final product of the weather. What stakeholder, finally 6, a stakeholder needs the information, that's what. A stakeholder needs the information, just whether it is hot, whether it is cold, whether it is rainy day, whether it is a warm day, that's what is the heavy rainfall or extreme event. That's what is required by the stakeholders. Now, here, the dynamic system is the one which evolves over time, number one. Number two, to ensure that the variables follow certain rules. They should follow certain rules, certain laws, like momentum, mass, conservation of momentum, conservation of mass, conservation of energy, basic gas, basics. So we are not agriculture. We, the agriculture meteorologists, are expected to know only that one. So whether those variables are meeting the basic laws of physics, like this. Say for example, energy, basic laws of energy, first law of thermodynamics, the relationship among pressure, wind, and you can say temperature. Pressure, wind, and temperature. Sometimes you can say water vapor also. So we cannot deny it. Here, this is what is the dynamical system. So a dynamical system is the one which evolves with the time, number one. It needs some rules. So it also has to follow certain equations of you can say physics, basic physics, certain equations of motions, in atmospheric motion, in other words, so here now, so how the numerical weather prediction evolved over a period of time. History in the second class we discussed. Now in this class we try to understand how it evolved. Now see the progress of numerical weather prediction system. There has been a rapid progress in all the phases of numerical weather prediction. Wonderful, wonderful. See, synaptic forecasting, excellent. Statistical forecasting, wonderful. A combination of these two, dynamics, ensembles, excellent. But numerical weather prediction is, as I said in the first class, it is mostly mathematical and arithmetic equations are solved. Okay, they give the digital numbers and then which are converted into real forecasting. So numerical weather prediction over a period of time is gaining topmost priority. Now there has been a rapid progress. The improvements are mainly due to four things. The improvements that have taken place in the numerical weather prediction are due to four. Number one, considerable increase in the quality of meteorological data. Considerable increase in the quality of meteorological data we are getting from different conventional and non-conventional sources. Number two, advances in telecommunication system. So, I need not explain to you. Advances in the telecommunication system. Third one, tremendous progress in the computer technology. So, high-speed computers which can solve innumerable things at a particular time. The fourth one is the development of much better and sophisticated numerical models. Even though basic physics or basic structure from the computers are used, advances in the numerical weather prediction are enormous. Okay, now, so because of these four reasons, once again I would like to impress upon you that considerable increase in the quality of meteorological data. Number one. Number two, advances in the telecommunication. Number three, tremendous progress in the computing technology. And fourth one is the development of much better and sophisticated numerical models. They are sophisticated nowadays. Now, so even then, India, most of India or Asia comes under the tropics. However, in the tropics, still there are some lacunae or some issues to be addressed for better and better numerical weather prediction model output. What are those? See, what happens in the tropics? See, most of the area in the tropics is covered up to no, certainly land. However, mountainous regions, oceanic regions, desert regions, once again I will repeat, regions like mountains, regions like oceans, regions like deserts, there the density of observations, the quality of observations, the availability of past data in these areas are limited. This is number one. Number two, of course, wind pressure gradient is less. That means Coriolis force is less in the tropics. That is number two. Number three, of course, in the literature of India Meteorological Department and certain very good books from, I also found that the gradient of temperature is also less. The gradient of temperature. The gradient of temperature is the driving force for so many things, in the thermodynamics. Of course, in the micrometeorology, I tried my level best to give Fourier's law, Newton's law of viscosity, Fourier's law, Fick's law of diffusion, whatnot. So, the temperature gradient there I told also plays an extremely important role, which is lacking in to a great extent lacking in the tropics. Another important feature that is a small limitation as far as the tropics are concerned is that the lack of precise understanding of sea and air interaction. Air is there over the land, air is there over the ocean. So, land, ocean, air. Okay, good. But the air over the land, the air over the, or atmosphere over the land, atmosphere over the sea, interaction or precise understanding is lacking. However, in spite of all these things, computing powers, understanding of different physical processes, observation technology, telecommunication system, what we discussed in the last 1 minute, around 1 minute. So these are making advances in the numerical weather prediction, no doubt. So the reliability of numerical weather forecast is much higher compared to that of the few decades. Now the reliability is much higher. So in India, numerical weather prediction models now include many complex physical processes and advanced data assimilation systems. So data assimilation we take from conventional, non-conventional, neighboring countries, even global models. So they are all wonderful network is there. So estimation system has also increased. So the National Center for Meteorology Weather Forecasting, Noida, New Delhi, has been a lead center in India for all weather and climate model related research and operations. This is what. Then NCMRWF is also carrying out developmental activities on the next generation weather and climate modeling. Next generation. Let us have 100% confidence on NCMRWF that he is doing wonderful exercise. We are going to solve all the problems. Now, so let us discuss the main aspect of today's class, components of numerical weather prediction model. So what are the components? Number one, there is a need for an input. From the input, you get the output. Fourth one, model output. So from the input, pre-processing is required. So there is a need for a model. Okay, there is an input, there is an output, 1 and 4. So there is a pre-processing, there is a model, and finally we get the post-processed, and then finally it goes to the stakeholder. Input, pre-processing, model output, post-processing, stakeholder. So these are the components of numerical weather prediction model. Now, weather at a place and time. Weather at a place and time is a function of basic meteorological parameters. Weather. Now, in our classroom, what is the weather we are facing? Outside our classroom, it is a function of place and time, at which it is a function of place and time with the basic meteorological wave. What are the solar radiation, temperature, humidity, pressure, wind, zonal wind, meridional wind, whatnot, vorticity, whatnot, different things. Now, so these are weather at a particular time is a function of a place and time with reference to weather variables. Now, if values of these basic, if the values of these basic weather variables are known correctly, we give them as the input. Okay, we give them as the input in the numerical weather prediction model. So okay, so in other words, we can say like weather forecasting is a function of weather forecasting. The responsibility of weather forecasting, otherwise, for a forecaster, is translated from weather forecasting to just forecasting the weather elements. First, he has to forecast the weather element in the numerical weather prediction. So then we get the final product and then it goes to the end users. Once again, I would like to impress upon you that the forecaster who is using the numerical weather prediction model has to translate his mind, shift his mind from forecasting to first forecasting the weather variable based on what? Initial values. So that is the importance of the initial values. Now, the question is whether it is possible to predict these parameters. Yes. Whether it is possible to predict? Yes, it is possible because wonderful basic equation of physics, excellent computer technology is available, sophisticated technology. So what is not possible? It is possible. So here I would like to say the fact whether these variables, first thing is whether it is a fact, there is a fundamental thing. Whether these variables satisfy the fundamental equations of physics. Fundamental equations of physics, you tell me several times. I told what are used in the numerical weather prediction. Several times. Conservation of mass, conservation of momentum, conservation of energy. In the energy, first law of thermodynamics, relation among pressure, wind, temperature, sometimes humidity. Okay, right, like that. So whether these variables are satisfying the fundamental requirements of the equation. Okay, so once there is an input, there is in the third part there is a model pre-processing. Now, in numerical weather prediction, these equations are integrated forward. This is the word. Please, integrated forward, integrated forward, integrated forward. Please remember, what is this? In numerical weather prediction models, these equations are integrated forward with respect to time and the constants of, if at all some constants are required, so integrations are computing the based on the initial value, some constants we will find out. Thus, without having complete knowledge of the initial conditions with reference to weather parameter, it is impossible to go for weather forecasting to numerical weather prediction. So now here a typical weather a typical numerical weather prediction basically is in the input, there is an output, there is a model, input to model, post-processing, this is second is the pre-processing, finally stakeholders are there. Now here in the pre-processing, input is the pre-processing, what we do? The values of weather variables are prepared at different grid points. Different grid points. As I said several times, numerical weather prediction models are wonderful, excellent at small grid points. So, innumerable grids we take it, we ensemble them later. Now, so at the grid level, what we do is the meteorological variables are prepared at the grid level in the pre-processing grid level. So, with the initial conditions, the equations are numerically integrated forward. Again, see the equations are numerically integrated forward with the time in the model. That is the dynamic, with the time in the model. Once there is a pre-processing in the grid level. So in the model they go. Then future values of these variables, that's what I told. The forecaster's responsibility shifts first from forecasting the weather to forecasting the weather variables. Forecasting the weather to forecast weather variables. First, it is his responsibility. Then comes, the model will take care of what is the graphic, what is the decimation, what is archiving, what not, everything. Even several things it will take. Now, so in the post-processing unit, specific weather information is generated. For weather information, it is an extreme event, it is a very plain event, whether it is a fair event, everything like that. So this is what with reference to the basics of the components of the weather system. Now here, just for a minute or two, I would like to discuss with you an important thing, ensemble forecasting. Beloved students, you always get a bit. Please listen this statement. Ensemble prediction is a ensemble, ensemble forecasting, in other words. Ensemble prediction or ensemble forecasting is a new tool. It is a new tool for operational forecasting that allows for more rapid and scientifically based comparisons of multiple model forecasts. Scientific comparisons of multiple model forecasts. This is ensemble forecasting. Once again, just I would like to, in the ensemble forecast, what we do is it's a tool. It is a small tool. Like when you go to the bank, you give a tool, check, you get the money. Like it is a tool for operational forecasting that allows for more rapid and scientifically based comparisons. More rapid and scientifically based comparisons of multiple model forecasts. Different models are, different forecasts are there, but scientifically, the comparisons are made and we get the output. Now, ensemble products like, what we call spaghetti diagrams. And in the ensemble forecasting, the product, wonderful products are there. Number one in the ensemble forecasting is that you get a wonderful diagram. So what is the diagram? Land is there, land is here, land. So there is a water here, maybe snow here, water and snow here. Now in the land, there is a vegetation. In the land, there is a soil. Land and soil, you know the difference. Now, so as you go up, so the soil has some roughness. As you go up, clouds may be there. But when clouds are there, so the solar radiation reflected, absorbed, transmitted, or scattered. Then comes from the water, there is an evaporation. Once evaporation is there, there is a condensation, there is a cloud formation, there is a possibility for rainfall. So like this, vegetation may be there. All these things in a wonderful spaghetti diagram figure the ensemble technique will give. Once again, I would like to impress upon you what is an ensemble technique. It scientifically analyzes the forecasts of different models. Scientifically analyzes and compares. Then final product is given in the form of first spaghetti diagram. This is how a spaghetti, say for example, a spaghetti diagram which has got so many models are there, for example, so many models are there. One model gives like this, one model gives like this, one model gives like this, another model gives like that. So the confidence is less in that case. So what we should do, we go back to the numerical weather prediction instead of a coupling. So now, if so many models are giving close, very close, very close, very close, very close output, then it is called as high confidence. So depending upon the density of the graphs we get from different models, ensemble technique will give us a wonderful output. Now, so ensemble products like spaghetti diagrams use statistical and graphical methods to combine multiple model runs, each based on slightly different initial conditions or using slightly different model configurations or parameterizations. What I told was the parameterization. Say in the ensemble technique, 4 models are easily okay, what you call are incorporated. Now 2-3 models are not. So we go for parameterization, or we go for initial conditions estimation scientifically. We give the weights. So there is absolutely no problem in that. And finally, with ensemble prediction products added to their new numerical weather prediction output. Ensemble products are also. What is ensemble products? This is for example, this is what I would like to say. So an ensemble model spaghetti diagram. Okay, sparse. So different models will give different outputs. Okay, all models give almost same. Is excellent. Confidence is less. That's what. Now, so forecast to the numerical weather prediction model kit. Now ensemble technique. The outputs are also added nowadays. The weather forecasting through numerical weather prediction is highly reliable. Okay, it is one of the, this is, I can say in one word, this is the best numerical weather prediction model. I am not denying, I am not questioning the validity or the wonderful synoptic models are there, wonderful statistical models are there, wonderful dynamical statistical models are there. I worked on them, I learned them. They are excellent and wonderful. Equally, of course, in the contemporary science, numerical weather predictions are the best. This is what the scientists are saying in the meteorology. Thanking you very much for your patient hearing.